Okay. Okay, so cumulative, so you see the second column, which is for distance. So you can see at every checkpoint, the distance is increasing by 1 mile. Right, from the start point, the distance is increasing by 1 mile. And then you see the third column is travel time. Okay, and both distance and travel time are cumulative values. So all of them, all the values in these two columns are from the start point. Okay, the distance from the start point, the travel time is also start point. So 0 was started when we were at the start point. Okay, it is easier to note down the cumulative distance and travel times during the travel time observation. Okay, rather than having distance and travel time for each section in the field, its cumulative is much easier. Okay, because if you want to have it for each section, then after crossing every checkpoint, you have to reset the watch, you have to reset the distance measuring instrument, and so on. So to avoid this, distance and travel time are measured as cumulative values from the start point, and later on you can calculate it for each section as well, or between two checkpoints as well. I'll explain it in this example later on. Now, if you remember, I said yesterday that the observer can also observe the delay, the stop delay, for how much time the car was stopped. And the procedure for that was you have a separate stopwatch with the observer, and that stopwatch will be started when the car stops. And when the car starts moving again, you switch it off. You note down the time and you can switch it off. So since you are starting and stopping the watch anyways, so you can have the observation for each section from that stopwatch. Okay, and obviously the stop delay does not happen so frequently, right? Maybe the car is moving for 5-10 minutes, 15 minutes, and then you have a stop delay. So for a stop delay, you have enough time to record and note down the observation for each stop delay or for each section, stop delay in each section, quite comfortably. Okay, so for stop delay, we don't record the cumulative values. We record the value for each section there. So the values in these two columns, I think this is fourth and fifth column, right? So fourth and fifth column values are not cumulative, they are for each section. You can see it is written with the heading as well. Okay, so if I say 42.6 seconds of stop delay, this is not from the start point. This is from between MP 17 and 18. This is for the section between MP 17 and 18. Okay, and number of stops, how many times the car was stopped in these 42.6 seconds? 3 times. Okay, similarly, this 46 seconds is between MP 18 and 19. And the car was stopped between these 2 points for 4 times. The car stopped 4 times and it consumed a delay of 46 seconds. Okay, then this column is calculated. This is the only column in this table which is calculated. That is a section travel time. Now, can someone tell me how would I calculate the section travel time? Can someone tell me how would I calculate the section travel time? Go ahead. From this table, how would I calculate the travel time for each section? So how do I get these values? Yeah, we take the difference of the cumulative values. Good. Okay, simple. Take the difference of the cumulative values. So for the first value, it's from the starting point, it's the point next to the starting point. So this will remain the same. The first section is from the starting point. So the value will remain the same, 1 minute 35 seconds. The second section is between 16 and 17, right? MP 16 and 17. So I have to subtract these two values. Okay. Now keep one thing in mind. This is minutes and seconds. So 1 minute 35 seconds and 3 minute 5 seconds. Okay. A common mistake here is people, when they are subtracting these two values, they put 3.05 minus 1.35. This is wrong. Okay, 3 minute 5 seconds is not equal to 3.05, and 1 minute 35 seconds is not equal to 1.35. 1 minute doesn't have 60 seconds unless you have barakah from Allah, and 1 minute extends to 100 seconds. 1 minute has 60 seconds. Okay, so 1 minute 35 seconds is not equal to 1.35. Okay, so either you subtract the numbers in minutes and seconds. Okay, so subtract first of all 1 minute from 3 minute 5 seconds, you will get 2 minute 5 seconds, and then from 2 minute 5 seconds subtract 35 seconds again. Okay, so this is how you do it. So when you do this, you will get 1 minute 30 seconds. Okay, so how did I get 1 minute 30 seconds? 3 minute 5 seconds minus 1 minute 35 seconds. And how did I get 2 minute 45 seconds? Again, you subtract these two values. So from 5 minutes 50 seconds, subtract first of all 3 minutes, you will get 2 minutes 50 seconds, and then subtract 5 minutes 5 seconds again, you will get 2 minutes 45 seconds. Okay, if you want to do it in a mathematical way, I can show you. Okay, if you can do it directly like I was speaking and doing it, well and good. If you cannot do it, I'll just show you a method. Okay, so that you convert, the method is convert everything to seconds, and then once you have the answer, convert it back to minutes and seconds. How? So you are subtracting 3 minute 5 minus 1 minute 35, right? So 3 minute 5 means 3 into 60, so seconds, plus 5, okay, minus 1 into 60 plus 35. Okay, the answer of this will be 90 seconds. 90 seconds means 1 minute and 30 seconds. Okay, similarly, if you want to do it for the second one, 5 minutes 50 minus 3 minutes 5, so 5 into 60 to 65. So this will give you 165 seconds. Okay, and 165 seconds means 2 minutes. 2 minutes is 120 seconds, and then you are left with 45 seconds. So it will be. Okay, so this is how you can do it. Okay, you don't have to follow this. Okay, this may take more time from you. Okay, if you can do it directly, minutes minus minutes, seconds minus seconds, I think that is more efficient. Okay, but if you cannot remember, convert everything to seconds, subtract it, and then convert it back to minutes and seconds. Okay, that is also good. Okay, so this is the only column which is calculated. It's calculated by taking the difference of the two cumulative values. The last column, again, something you observed in the field. Why were the cars stopping? In the last column, you are writing why were the cars stopping. Okay, so between this section, MP 17 and 18, the car stopped 3 times. Why? Because of 3 signals. Okay, between 18 and 19, the car stopped 4 times. Why? Because of a signal and because of some cars which were double parked and they were intercepting the flow on the road. Okay, so in the last column you have the reasons. So if you take the last value from the distance column, you will have the complete length of your highway or the complete length of your study section. If you take the last value from the travel time column, you will have the total travel time from start to end. Okay, so these are already cumulative, so you don't need to sum it again. And this is another mistake which students can make. They take the summation of the cumulative columns as well. Cumulative values are already summations. If you take the last value, that is a summation of the entire column, like the entire highway. Stop delay and number of stops, like I said, they are not cumulative. Okay, so if you take the summation of stop delay, you will have the total delay on the highway, and take the summation of the number of stops, you will have the total number of stops for the entire highway. And if you take the summation of this column now, because this is for each section now, okay, travel time for each section. So if you take the summation of this column, you should get the cumulative value again, the last cumulative value again, which you are getting here. Okay, so I hope this was clear. There were no calculations except for one column. Okay, Now let us start with some calculations. So we are given with an arterial, hypothetical arterial. Hypothetical means what? Imaginary. Okay, so we are imagining things now. We have gone completely mad after the exam, and now we are imagining things. Okay, so for this arterial, the true mean running time is 196 seconds over a 3-mile section. The standard deviation of running time is 15 seconds. Okay, and they are already saying that we know from previous knowledge, from experience, or obviously now we are imagining things, so it doesn't matter. So we imagine that normal distribution is applying to running times. So running times are also following normal distribution. What will be the average speed and 95% confidence interval speed on this arterial? So using the travel time, we have to calculate the average speed and the 95% confidence interval of speed. Okay. First of all, what do we mean by running time? Running time is the time for when the car was running. Okay, so this is different from travel time, because travel time may also or would also include the time when the car was stopped. Okay. So the difference between running time and travel time is the stop delay. So if you include the stop delay, we call it travel time. If you subtract the stop delay, then the remaining value will be called running time. Okay, now they are asking for average speed. Okay, calculating average speed is very easy. What should I do? Tell me, what should I do? How do I calculate the average speed here? Calculation of average speed. What should I do? Yeah. How do I calculate the average speed? The answer is in the first 2 sentences. How do I calculate the average speed? Yeah, anyone? People are sleeping. Raneem, Hussain. Average speed should be very easy. Yeah, see, distance upon time, d by t. Distance is 3 miles and time is 196, right? So give me the average speed here. Since now for this same highway, you can also calculate the average or mean speed using travel time. So for the sake of keeping it exclusive, I will write here mean running speed. Okay, so that you understand, you keep the difference in mind, because we are calculating it using the running time. Okay, so it will be 3 upon 196. Anything missing here? Should I do something with it, or just 3 upon 196 is enough? Should I do something with it, or just 3 upon 196 is the mean running speed? Am I missing something here? Yeah, you convert the time to hours, so it will be 3600. Okay, tell me. How much is this value? 22.04. Sure. Yeah, we converted time to hours. And what's the value? 3 upon 196 into 3600. What's the value? Okay, 55.1. Nice. Okay, that is done. No problem with it. Okay, there's no problem here. Now for 95% confidence interval, I will use the assumption which is given in the question, that running time is also following normal distribution. Because for normal distribution, I know there's a theorem named central limit theorem. We studied it in a spot speed topic. Now keep one thing in mind. travel time and spot speed are in the same chapter of the textbook. Why? Because the calculations which you can do for spot speed, the equations and theorems which apply to spot speed, they can also be applied to travel time. So in these questions, the calculations which you will do today and tomorrow and maybe further, you will see I'm using the same equations which I have shown you for spot speed. Okay, so I will keep on using the same equations. So there are no new equations, no new theorems here. For spot speed, in the topic of spot speed, we have discussed that normal distribution follows central limit theorem, and central limit theorem says 95% constant interval is mean minus 1.96 E. And E, again, same equation. E was equal to standard deviation upon square root of n. In this question, standard deviation is given, right? Standard deviation is given, but n is not given. We don't know the number of samples here. Why? Because in this question, you don't need to calculate E. You don't need to calculate E. Why? I will tell you the reason. Now, if you read this, the first line, last few words, they are saying true mean running time. The word true in statistics has a special meaning. What is the meaning of the word true? True means that it is for the entire population. It is not for a sample. So the mean which is given here, 196 seconds, is not the mean of a sample of travel time or a sample of running time. This is the mean for all the drivers who have driven on this arterial. Okay. So the word true, so if I say true mean running time, that is the mean running time for all the drivers on the highway, not a sample. If I say true maximum value, that means the maximum travel time which you can have on this highway for all the drivers, for any sample. Okay. Now, if you are using true mean running time, then you don't need to calculate E, because E is calculated for a sample. So if you already know the mean running time for the entire population, then you can directly take S, standard deviation, equals to E. Okay, if true mean running time is given or true mean value of something is given, then E equals to S. Okay, E equals to S. Standard deviation can be replaced, E can be replaced with standard deviation. Okay, so in this example, since true mean running time is given, I don't need to calculate E. I directly take the value of standard deviation and replace it and replace E with it. Okay, so wherever true mean is given, E is not to be calculated. Just use S in place of E. So going back there, so I will delete it from here so that you don't get confused. Mean is 196 and 1.96 into 15. And this relationship is coming from the central limit theorem. Okay, this equation is central limit theorem for normal distribution for 95% confidence interval. We already studied it. So give me the range here. What is the range for 95% confidence interval running times? It cannot be minus. Travel time cannot be minus. Did I make a mistake here? No. 15 into 1.96 will not be so high that you get a minus answer. I think you are multiplying 196 again. Yeah, thank you. Okay, then calculating speed is not a problem. Now we have the two values for the time. Again, we will do distance upon time, right? So maximum 95% speed will have 3 miles of length upon 166.6 into the conversion. How much is it? And same way you will calculate the minimum as well. $64.8. Okay, the minimum 47.91. Okay, so are there any questions about the calculation we just did? Do you have any questions? Okay, so I will move forward. The next question. Now, in this question, it is slightly different because first of all, now you have a bar diagram. So no numbers are given, no table, no numbers. This is a bar diagram. This particular bar diagram is also known as a histogram. In Excel, you call it a histogram. In statistics, you call it a histogram. You guys may be calling it bar diagram, but this is a histogram. A histogram is another representation of frequency distribution. A histogram is another representation of frequency distribution. So for spot speed data, you saw one type of frequency distribution which was shown with a curve. Okay, so we made the bell-shaped curve. For travel time, this is another representation of frequency distribution, which is shown for travel time. So what do we have on the x-axis? We have the values of travel time. On the y-axis, we have the number of observations for each travel time value. Like we had for spot speed data, the middle speed and the number of observations for that speed group, right? It's the same thing, but it is plotted now graphically. So the x-axis is like the middle travel time, and on the y-axis you have the number of observations. Okay, so 150 seconds of travel time was observed for how many vehicles? 1. Same thing for 160 as well. 170 seconds of travel time was not observed at all. 180 seconds of travel time was observed for 1 vehicle, 190 for 2 vehicles, 200 for 5 vehicles, and so on. Okay, so this is the number of times you observed each value. Okay, now they are saying calculate average and 95% constant interval of travel speeds, because these values are now travel times. They are not running times, they are travel times. So if you calculate the speed using them, that will be travel speeds. Okay, that's why I made the classification in the previous example as well, so that you don't get confused. Okay, now for frequency distribution, if you want to calculate the mean, we know the equation, right? The equation is this one. These are the equations. This is the equation for mean. Okay, so if I want to calculate mean, I have to do summation of n into s, or say n into x. Okay, so in this case, x will be the travel time and n is the number of observations. X is the travel time you have on the x-axis, and n will be the number of observations you have on the y-axis. Okay, so 160 is the value on the x-axis into 1, because it was observed one time. Okay, plus one, I should start from 150. 150 into 1 plus 160 into 1, both are observed one time. 170 not observed at all, so I just leave it. Okay, so the next value observed is 180. So 180 again observed one time. Then I have 190 twice, 200 5 times, I have 210 not observed, so 220 observed 3 times. Then 240, 50, 60 observed once. 240 plus 250 plus 270 observed 3 times. Okay, so the numbers which were multiplied by 1, I'm just skipping the 1, okay? Plus 280. This whole thing divided by total number of observations. Total number of observations. How many observations you have? What is the total number of observations we have? Tell me. Total number of observations in this study. How many? $20. Okay. How did you find it, Haya? How did you know there are 20? What did you count? And this is important, okay? This is important. So how did you get that they are 20? How did you know we have 20 observations? Anyone? How do I know the number of observations? Okay, okay, okay. You have the idea now. Yeah, good. Okay, good. Okay, so 1 and 2 and 3 and 190 observed twice. Okay, so this is 4 and 5. Okay, then 200 observed 5 times, so 5 plus 5 10, and 220 observed 3 times, so 10 plus 3 13, then 14 15 16, then 16 plus 3 19 plus 1 20. Okay, so count the number of observations. Again, a common mistake from the students is they count the number of values, like 150 plus like 1. So 1, they counted like this: 1 2 3 4 5 6 7 8 9 10 11. Okay, so 11 will be wrong, because 11 is the number of values you have on the x-axis, not the number of observations. Number of observations will be the summation of the values which you have on the y-axis. Okay, same mistake I pointed out for the spot speed table as well. Then don't count the number of groups you have, count the number of observations for each group and then add them together. Same rule applies here. Okay, don't count the number of values. I have 11 values, so 11 observations. No, because some of the values are observed more than once. Okay, so count the number of observations and then add them together. So they are 20. Okay, give me the mean travel time. How much is it? Okay. Okay. Then you can calculate the mean travel speed, right? Using travel time, so I will use travel speed. So the length of the segment, same, 3 miles. Time, then the conversion to hours. How much is it? Mean speed. (49.43 miles per hour). Okay, now I will apply the same equation for calculating the 95% confidence interval. In this case, for the case of this example, tell me, should I calculate E or not? Tell me. Should I calculate E in this example or should I not calculate E? I should calculate Y. Why should I calculate E here? Yes, we have a sample. Good. Good. Haya, Rani, well done. We have a sample. Okay, so E can be calculated. The mean is not for the entire population, it is for a sample. So E must be calculated. So E is S upon square root of N. Okay. So I need S, right? I need standard deviation. Okay. The equation for standard deviation, again, for frequency distribution data is this one. I need to calculate the standard deviation. Now for in standard deviation, you take this bracket and instead of multiplying with x, you multiply by x square. Okay, the equation will come. I don't know when it will come. Okay, so instead of multiplying with only s, I need to multiply by s square or the value of the travel time square. Okay. This whole thing is in the square root. So it will be 150 square. I don't need to write 1. Okay, so you complete this bracket, then you have to subtract n, which is 20, into x bar square. X bar is the mean, so 218.5 square bracket as well. So this is your numerator, and the denominator is capital N minus 1, number of observations minus 1, which is 19. Okay. So calculate the big bracket first. Okay, calculate this bracket first. Then you can subtract this value, and then whatever the answer you get, divide by 19, then take the square root. Yes, anyone? $38.29. Okay, good, good. The standard deviation has the same units as the quantity itself, so seconds. Now I can calculate the e value. Give me the e value then. It's 38.29 divided by square root 20. How much is it? The e value? .56. Then you can calculate the 95% confidence interval, which is mean 218.5 plus minus 1.96 into 8.5. Okay, how much is this interval? Once you know the interval, you can calculate the maximum 95% speed, minimum 95%. Yeah. Confidence interval, how much is it? This value. Okay. Okay, then you can calculate these values then. Give me the confidence intervals for speed. $53.54 and 49.4, 45.9. Okay, before we move on to the next part, we calculated mean speed here, right? This one, mean travel speed. Now, whenever we calculate speed, mean speed, you can either call it time mean speed or space mean speed, right? In this question, I have used travel time of the segment to calculate the mean speed. Which speed is it? Is it time mean speed or space mean speed? Tell me. The speed which you have calculated using the travel time, is it time mean speed or space mean speed? No, yes, this is space mean speed. Space mean speed. Okay. Because you are using the travel time of the entire segment. Okay, so the main idea of space mean speed is that travel time of the segment is used for calculating the speed. Okay, entire segment, not a short spot like what we discussed for spot speed. Okay, we are talking about the travel time of the entire segment. Okay, so it was a 3-mile segment, a very long segment. You were using the travel time to get the speed. Then it is space mean speed. Okay, if the distance was, let's say, 100 200 feet, and then you use the time to get the speed, that will be time mean speed, because that is not the entire segment. That's a very short part of the segment, a spot or a point. Okay, so this one is space mean speed. Why? Because you are using the travel time of a very long section to calculate the speed. Then it is space mean speed. Okay, now you have, let's say, the previous example which we did, this one for about running time and this one about travel time, are both for the same highways. Let's say both of them are for the same highways. So I have the running time and have the travel time. If I want to calculate delay, I can just simply do this. Mean delay equals mean travel time minus mean running time. Okay, so 218.5 minus 196 will give you the mean delay. And how much is it? How much is this difference? 22 point. Okay. So one way of calculating the delay is find out the running time and the travel time. You take the difference, you get the mean delay. Okay. Another way of finding out the delay is using the possibility or probability of having the delay. So which is shown in this question. So we have a highway. The highway has two signals. Okay, so they have observed the average time for which a car is stopped on each signal. So if you are stopped on one signal, you will on average be stopped for 40 seconds. If you are stopped on both signals, then on average you will be stopped for 80 seconds. And they also observed the percentage of cars which do not have to stop at any signal, which have to stop at one signal, and which have to stop on both the signals. So 56.9% cars do not have to stop on any signal. The signals are so well designed, the cars can keep on moving without the stoppage. 56.9% cars or 56.9% vehicles can move without stopping. So for these 56.9%, the duration of stop or duration of delay is 0. Then 30% cars had to stop on one of the signals. So for them, the average delay was 40 seconds. And 13% cars, 13, had to stop on both signals, and their average delay was 80 seconds, 40 seconds for each signal. So they had to stop on 2 signals, so their average delay is 80 seconds. How do I find out the mean delay using these values? I'll multiply the duration with the possibility of having that duration. The duration of delay with the possibility of having that delay. So what I will do, mean delay equals possibility is 0.569, 56.9%. What is the duration of this possibility? 0. So there's 56.9% possibility you will have 0 delay. So I multiply them both. Then 30% possibility of having 40 seconds of delay if you have to stop on one signal. Okay, and 0.31 possibility, 0.131 or 13.1 possibility of having 80 seconds of delay. You stop on both signals. So you add all the products together, you will get the mean delay. So what did I do? I took the duration of delay, multiplied with the possibility of having that duration. Okay, and then you add them together, you will get the mean delay. So how much is this value? Can someone give me this value? Yeah, almost the same, right? Because the whole example is for the same highway. So I showed you can calculate delay using travel time and running time, or you can calculate delay using its possibility and the duration. Do you have any questions for any of the examples? So you have done 3 examples, right? One for running time, one for travel time, and one for delay. Okay, and before that I showed you the table for travel time observation. Any questions regarding them? All of them are clear? Any suggestions, any queries? Okay.
Thank you very much, sir.
Yes, Hussain. New picture, huh? Looking good.
Thank you, sir.
Okay. I should say mashallah, right? Otherwise your hairs will fall off. Okay, thank you for listening. Thank you for participating. All of you have a good day. See you all tomorrow, inshallah, with some more calculations. And Assalamu alaikum.